Okay, so now that you know how to find the slope, this should be really easy for you. I have the line all set up already and the coordinates for your first dot in green, the 1, comma 2, and your coordinates for the end dot, the second dot, 5, comma 4, all set up. So if you take y2 minus y1, that would be the 4 from your second set of coordinates minus the 2 from your first set of coordinates all over the 5 from your second set of coordinates minus the 1 from your first set of coordinates. And if you subtract those, 4 minus 2 is 2, 5 minus 1 is 4. So you'll end up getting 2/4. And if you remember from basic math, 2/4 can be reduced down to 1/2. So 1/2 would be your slope. You can reduce these slopes down to their basic form. You can also look at like this. If you just take the second set of coordinates, 5, comma 4, and you subtract the first set of coordinates, 1, comma 2, and you just subtract those, then 4 minus 2 is 2, 5 minus 1 is 4. So you just put the 2 on top and the 4 on the bottom, which will give you 2/4. And 2/4 can be reduced down to 1/2. And that's the slope. Now, another way you can do this, which is the way I prefer to do it, and I think it's more of a shortcut, is if you just start at the starting point. Start at the first point, your 1, comma 2, and you count up however much it takes to go up, which is 2 notches, 1, 2, so that's 2 notches, and then you go over however much it takes to go over to your second point, which is 1, 2, 3, 4 notches. That 2/4 is going to be your slope, which is the same thing as 1/2. Because if you look at your first point and it takes 2 notches to go up and 4 notches to go over, 2 notches to go up, 4 notches to go over, that is what is called with your slope, that is what is called the rise and the run. And that is what you officially call the slope. So the rise, the top number in the fraction bar, is how many it takes to go up, and the run on the bottom of the fraction bar is how many it takes to go over. So your rise over your run is 2/4, and that reduces down to 1/2, which is your slope. So once again, the rise from your first dot to your last dot is 2 notches, and the run is 4 notches. So 2 notches over 4 notches. Rise over run. Because rise, of course you're going to put that on top of the fraction bar because that's rise, and run goes on the bottom of the fraction. So let's try this again using my shortcut for the rise over the run. So we have our first dot here on the left, and we're going to go up 1 notch, 2 notches. So that's the rise. The rise is going to be 2. So let's put 2 on the top, and then you're going to go over 1, 2, 3, 4. So the run over is going to be 4. So that's going to give you 1/2. So the rise is 2 and the run is 4. So let's try that again and see it'll even work if you're in a different quadrant, if you have negative numbers too, because this would be a negative 3x. This first dot would be negative 3 for your x value because it's to the left of the 0. But it doesn't matter. It doesn't even matter what the coordinates are. You just count up from the first dot to the second dot. So you go 1, 2, 3. So your rise is 3, and then you go over 1, 2, 3, 4. So your run is 4. So your rise is 3, and your run is 4. So your slope is 3/4. So let's try this again. So we start with our first dot, and we go up 1, 2, 3. So your rise is 3. And then we go over 1, 2, 3, 4, 5, 6, 7. So your run is 7. So rise over run. And that's your slope. Now here's another little trick about finding the slope. You don't have to start with the beginning point and the end point. You can start with any of the points and do any of the points within the line as long as it's a straight line. So if we did start with the beginning point and the end point, we would count up 1, 2, 3, 4, 5. So your rise would be 5. And we would count over 1, 2, 3, 4, 5, 6, 7 and a half. So your run would be 7 and a half. So we would put that 5, your rise, over your run, 7 and a half. But if we started with any of these other points, it would give us the same thing. We could start with this point here and go up 1 and go over 1 and a half. So your rise would be 1 and your run would be 1 and a half, which would turn out to be the same thing. Because if you reduced this fraction from 5 over 7 and a half to 1 over 1 and a half, you would see that it's the same thing, because 5 divided by 5 is 1, and 7 and a half divided by 5 is 1 and a half. So it would be reduced down to the same thing. It's still the same slope. It's the exact same steepness all throughout the straight line. If it's a straight line, then the steepness is not going to change. Now, if the line went up and then it went over, then of course the steepness changes, but that's not a straight line, is it? So if it's a straight line, then the steepness will never change, whether you start at the beginning and go all the way to the end to find the rise and the run, or whether you start somewhere in the middle and end up somewhere in the middle to find the rise and the run. It's still going to be the same steepness. So let's show that one more time picking any points within this straight line. Now if we start, say, halfway up right here, and we want to go to the next dot, we're going to go up 1 and over 1. So in this case, your rise would be 1 and your run would be 1. So that's your slope. So now let's try it doing the beginning and ending dots. Here's the beginning dot, your first dot, and you go up 1, 2, 3, 4, 5, 6. And then you go over 1, 2, 3, 4, 5, 6. So that would be 6 over 6, which reduced would be the same thing as 1 over 1. So as you can see, as long as it's a straight line, it doesn't matter where you start and stop within the line. You just have to start somewhere in the line and stop somewhere in the line, and you always want to go from left to right. Just like we read from left to right, you want to start on the left side and you want to go toward the right side. As long as you do that, you're going to find the right slope. Just be sure if you get a big number, like 6 over 6, or if you get 2 over 4 even, make sure you reduce that down to its simplest fraction. So this 1 over 1, we would actually just say the slope is 1, because 1 over 1 equals 1. So just do left to right and reduce it down to its simplest fraction, and you'll be fine. Now let's go back to this problem for a minute. This rise over run 1 over 1.5. So I bet you're thinking, what the heck is going on? You can't have a fraction within a fraction. You can't have 1 over 1.5. Well, that's just a matter of basic fraction rules. If you want to change this into a proper fraction, so you don't have this 1.5 on the bottom like this, you just take both the top and the bottom by 2, and so you end up getting 2 over 3, because 1 times 2 is 2 and 1.5 times 2 is 3. So now you have a proper fraction of 2 over 3. So that would actually be your real answer of the slope, is 2 over 3, not 1 over 1.5. So just keep it simple. And if you end up getting something like this with a half, don't worry about it. Just roll with it, and then you can always change it to its proper fraction at the very end.